to the original line, and here's the slope-intercept form of that. Now, another thing we do in this section is we take a look at creating a linear model. And basically what we're doing when we create a linear model, we find an equation that describes a particular set of points. So what you need to do is turn to page 459 in your text. If you don't have the printed textbook, you might want to print that page, pause this recording and print the page, and then come back and finish watching. Okay, in 68, we're doing nuclear waste, and we have a table. It says the table gives the heavy metal nuclear waste in thousands of metric tons from spent reactor fuel stored temporarily at reactor sites awaiting permanent storage. And they tell us where that comes from. And it says let x represent equal to 0 represent 1995, x equal to 5 represent 2000, and so on. Okay, so plot the ordered pairs. Do the points lie approximately in a line? Okay, so I'm going to need to open the journal here so I can get a piece of graph paper. All right, graph. All right. Okay, so here are the points. Let's see, 68. Okay, so 1995 is 0, so I'm just going to list them. Okay, and then the 2000 will be year 5. 2010 will be year 10. Okay, no, it's going to be year 15. Get that right. And that's 61. And 2020 is going to be 25. And that's 76. All right, so here's actually, I'll go ahead and put it over here. I hate to make a mess here. Let's put 0 here, 5, 10, 15, 20, 25, 30. So that's our year. And go up to 76. So 10, 20, 30, 40, 50. I don't quite have enough, so I won't quite finish that, get that 1 point up here. I got up to 70, so I should have planned a little bit more space here. Okay, so 0, 32, 5, 42, 15, 61, and 25, it's going to be up about here. So the question is, does it look like a line? And my response to that question, I would say yes. This is part A. Okay. It says use the ordered pairs 0, 32 and 25, 76 to find the equation of a line that approximates the other ordered pairs. Use the form y equals mx plus b. Okay, so if we think about our slope, it's going to be 76 minus 32 over 25 minus 0. 76 minus 32 over 25 minus 0. So we're getting 44 over 25, okay, is our slope. And let's use, this is actually the y-intercept, 0, 32. So y equals 44 over 25 mx plus our y-intercept is right here. We can see it. So that would be our equation. And it says use the equation from part B to estimate the amount of nuclear waste in 2008. Okay, 2008, this is part B, minus 1995 would leave us with 13. Okay, so that means our x is 13, and we want to plug it in here. Times 13 plus 32. Grab my calculator. Looks like I have put it somewhere else, so I guess we'll multiply this out. 12, 132, 4, 4, 2, 7, 5. So that's 572 over 25. And let's say 25 25ths. Okay, ended up getting my calculator after all. All right. 44 divided by 25 times 13 plus 32. All right, I'm getting 54.88. So y would be about 55 for that. Okay, so that's what we mean by modeling. What we do is we're taking a series of points. We're looking to see if the points more or less line up. If they do, we come up with an equation of the line that those points would be located on. And then we can use it to make predictions about other years that are not, in this case, in our table. So for 2008, we would guesstimate approximately 55,000 metric tons of waste in that particular year. So we do have to look at the units that are given in the problem. So that's what the linear modeling is all about. Okay, your next step will be to watch the recorded sample problems for this section. I'll do a few more examples in case you need a few more in order to feel comfortable before you do the online homework.